A circle is described as a collection of points in a plane which are at an equal distance from a fixed point. The fixed point is called the center, and the constant distance of all points from the center is known as the radius of the circle. Here, the radius is denoted as r. A chord of a circle which passes through its center is known as the diameter. It is denoted by d. The longest chord of a circle is the diameter and is twice the length of the radius. The length of the boundary of a circle is known as its perimeter or circumference. The circumference is given by the formula 2 pi r. The perimeter of circle is measured in linear units like centimeter or millimeter. The area of a circle is the amount of surface enclosed by the boundary of the circle. The area is given by the formula pi r square. The area of a circle is measured in square units like centimeter square and millimeter square. In a circle, the ratio of the circumference to the diameter is always constant, denoted by the Greek letter pi. From this, we get the formula for the circumference as 2 pi r. The decimal expansion of pi is non-repeating and non-terminating. The value of pi is taken as 22/7, or 3.14 for practical purposes. Its approximate value was given by the Indian mathematician Aryabhatta, who discovered pi is equal to 63,832 divided by 2000, which is 3.1416. Tap the buttons to understand this better with more examples. Fill in the blanks with the correct values. 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 A continuous section on the circumference of a circle is known as an arc of the circle. Here, PQ is an arc of the circle. 2 points on a circle will split the circle into a larger and a smaller arc, which are respectively known as major arc, minor arc. If the points lie on the ends of a diameter, the 2 arcs will be equal. That is, they will be semicircles. The arc with an angle measurement greater than or equal to 180 degrees, or if it forms more than a semicircle, is known as the major arc of the circle. The segment of a circle is the portion bounded by a chord and its corresponding arc. The portion bounded by a chord and the minor arc is known as the minor segment. The portion bounded by a chord and the major arc is known as the major segment. If the chord separating two segments is the diameter, both segments are of the same size. In this case, both segments form semicircles. The portion bounded by two radii of a circle and their corresponding arc is known as the sector of the circle. The portion bounded by two radii and the major arc of a circle is known as the major sector of the circle. The portion bounded by two radii and the minor arc of a circle is known as the minor sector of the circle. The angle of the major sector is always equal to 360 degrees minus the angle of the minor sector. Let us now try to find the area of a sector of a circle. Let us consider a circle with center O and radius r. Here, OLNM is a minor sector of the circle and angle LOM is equal to theta. The circle can be seen as an arc that subtends an angle of 360 degrees at the center O, and the area of the circle is pi r square. This means that the area of a sector that forms an angle of 360 degrees at the center is equal to pi r square. And the area of a sector having an angle of 1 degree at the center is equal to 1 divided by 360 into pi r square. Let us now find the length of an arc using a similar method. We know that the length of the entire circle is equal to circumference, is equal to 2 pi r. This is also an arc that forms an angle of 360 degrees at the center. So, the length of the arc that forms an angle of 1 degrees at the center, 1 divided by 360 into 2 pi r. Thus, the length of the arc LNM that forms an angle of theta at the center, theta divided by 360 degrees into 2 pi r. Consider a circle of radius r and chord LM subtending an angle of theta at the center. Here, LNM is a minor segment. From the figure, we can say that the area of the minor segment LNM is equal to the area of the sector OLNM minus the area of triangle OLM, which gives us area of the segment LNM is equal to theta divided by 360 degrees into pi r square minus area of triangle OLM. To find the area of the triangle, we can multiply half of its base with its height. This can be written as half of LM into OZ or LZ into OZ. If we consider the right-angled triangle OLZ, we can see that LZ can be written as r sine theta by 2 and OZ as r cos theta by 2. Using a trigonometric identity, we find that the area computes to 1 by 2 r square sine theta. Substituting this value, the area of segment LNM will be. To find the area of the major sector, we subtract the area of the minor sector from the area of the circle. Similarly, for the area of the major segment, we subtract the area of the minor segment from the area of the circle. Tap the buttons to understand this better with more examples. Fill in the blanks with the correct values. Fill in the blanks with the correct values. Fill in the blanks with the correct values. Fill in the blanks with the correct values.